Hi, I'm Joshua. I'm an INTP. First and foremost, thank you for visiting this video. Now, I would like to say that this video is going to be referencing a previous video I made on reality as an information-rich matrix. In that video, I talked about a specific type of system, which is a self-organizing system, and I described nature in these terms. I don't feel in hindsight that I gave enough description about what a self-organizing system is for an audience to get a feel for just exactly what it is I'm describing. And so I want to talk more about self-organizing systems in this video and why they're peculiar and why they're interesting and why they have relevance to cognition and perception. Firstly, a self-organizing system is analogous, I said this in the previous video, to a double-arm pendulum, meaning that it is chaotic in nature insofar as its patterns of change and variance, how it is changing over time and what that change shows up as in the environment or at the time of observation is idiosyncratic and irregular in its dilations insofar that it doesn't have a succinct harmonic motion of change to it. It doesn't have this draw of up and down, this causes this, therefore that type of pattern in change, or literally this, I don't want to say simply the slope, because it's just not that simple. It's not a linear model of viewing the world, and nature, it behaves in this manner. In the previous video, I mentioned the example of global warming, and I would like to start from this standpoint in saying that when you're looking at variables in a system, in particular a self-organizing system, it's important to understand that the variables themselves, they have magnitudes in relations to one another. It's analogous to having a glass of water and putting a sweetener in the water. If you take regular cane sugar and put that in the glass of water, it will take much more cane sugar to make the water a certain level of sweetness as opposed to putting in packets of Splenda or any artificial sweetener which has a different chemical makeup that creates such a more visceral and palpable potency to its level of sweetness, or what the brain registers as being sweet. You don't need as much Splenda or stevia to make something sweet as you do regular cane sugar. It's because these sugars, or these artificial sweeteners, are exactly sugars, they're acids, but it's that these acids, they convey the effect, they convey the change in a much more rapid and robust rate than cane sugar, given its molecular content. And when I'm talking about a self-organizing system, I'm saying this in particular, that change, it is not something that is so easy to make out the why and the where and what exactly is causing what to occur. And that this change, it does not obey our intuitive notions of I touch the handle of the door and turn it and pull it, and therefore the door opens. It's not A causes B, or just merely B causes C, but something that is statistical and statistical and nuanced, insofar as to say this, that there is so much variability and there's so much chance that has to be considered, and randomness in its display, that it is only can be thought of in as a probabilistic expression. If those words would seem too convoluted, I'll say this, that it's like flipping a coin. It should go heads, it should go tails, and it should, in an ideal world, go heads one time and then tails the next, then heads another time, then tails the next. But it doesn't go completely heads or tails all the time in the sequence that it should happen, given that there's a 50-50 chance reasonably for either to occur. So if you flip it 4 times, you should get 2 times that it would be heads, and you should get 2 times that it would be tails. But we can't. It's because what causes something to be is not easily perceivable and is not easy to measure, because there's so much complexity and nuance in what variables actually are, what's actually out there in reality, the essential characteristics to it, and then how they relate to one another. And in a self-organizing system, you have these effect sizes, these things that are a measurement or a tool for the amount of change that's taken place or that will take place because of something. And these things, they don't obey this intuitive notion of you put in more, you get more, or you take and you take more, you receive less. It's not just this simple linear back and forth dynamic between things. It's very much a I can only say chaotic variance, because the patterns, they don't have nice elliptical shapes or motions to them. They're not parabolas, they're not just simple curves. They're mixed, and nature is like this. It's a mixed something. To keep it from going far too abstract or mathematical, I'll say that climate change, as I said in the previous video, is a good example of this. Is in, you don't need a ton of extra CO2 emission to have a drastic change in the way that weather patterns behave, and just what the actual ecological, not ecological, but biogeographical makeup of the atmosphere and land masses actually sit there and display themselves. It's quite it's just that this simplistic intuitive framework doesn't work when we're talking about what nature is. And a self-organizing system is something where a small change can produce a tremendous amount of difference in level of entropy and chaos in the system. For example, in Alaska, in Yellowstone, they sought to remove the wolf population, and they did not think that this would have a enormous effect on just the ecology of Yellowstone Park. But it turned out to be a travesty and put it into ruin, because you think if you remove one predator, that the ecosystem, it's not going to be greatly harmed and disturbed by this minute change, because it is a minute change insofar as it's only one species that has been removed. It's not like they removed the caribou and all these other things. They only removed the wolves for man-made serving reasons, but who cares about the reasons? It's just the act that happened. But this created just a great deal of trouble. Or another example is in Australia, when they introduced rabbits. They didn't introduce a ton of rabbits, but they got a ton of rabbits, and having a ton of rabbits caused a great deal of problems for Australia and the indigenous life there. You look at Michigan and the zebra mollusk. Just one invasive species showing up into an ecology that it did not evolve to be in, and the ecology is not suited for, will do a tremendous amount of harm to an ecology, and it can have a reverse effect, and not just being introducing entropy and chaos, but small effects over time have cascading effects insofar as that when something is reiterated, even if it is minute, and is carried it takes and speeds up the process of change. Things occur much more rapidly than that may even have been predicted or can be predicted what the changes should be. It's because self-organizing systems, they're systems that recognize that there are a multitude of variables that are contributing to the way something appears. It's to say that given the enormous complexity of reality, why change happens, why change occurs, is one of an infinite nature in complexity, and it's in keeping this that makes cognition in all behavior and all patterns of change better accessible and understandable. And I'll now turn to the brain. Insofar as this, that when you're looking at the brain and how it regulates the body and how it operates, how much of your brain is in control of you is rather interesting, insofar as the major portions of your brain don't really control the important actions or what occurs in the body, such as breathing, your heart rate, and your sex drive, your hunger, your thirst, even curiosity and the drive to explore the environment. Those are contained in the hypothalamus, which is a very, very tiny, small part of your brain that starts at the base and the stem of the brain. It's not even something that, if we had this thinking of the brain as just compartments, would even deserve a compartmentalized mapping of it if it just didn't do so much in the body's regulation and human behavior, because it's so minute, it's so small, yet it's responsible for tremendous action. It's at the seat of action. It's at the seat of regulation in some senses. The other example of a self-organizing system, insofar as it relates to the brain, because the brain itself is a self-organizing system. It's things such as the structure of the hypothalamus and the cortical structures, and how just mere neurophrenology, or the way the brain is arranged, just these slight differences in arrangement cause just tremendous differences in behavior or existence for a person. For example, you can lose an arm, you can lose legs, you can even lose a kidney, and it won't change necessarily who you are, insofar as I'm using an Aristotelian term, the essential characteristics of a person. It won't change those. It may, you're still going to have your personality, you're still going to be who you are. But if you have somebody who's overly aggressive and you do frontal lobotomies to them, they essentially become vegetables. It kills all aggression in them. They're no longer the same person. Or if you take a subject or a group and you raise the dopaminergic levels in their brains, whether they're introverted or not, they're going to act a lot more or what we would classically consider extroverted than another person. If you take somebody and if you just change the neurochemical ratios within any individual's brains, you're gonna change who that person is effectually, and that is something that's indicative of self-organizing systems. That small and minute changes, small and minute effect sizes, small and minute variances, when those things are aggregated over time, or just even randomly present at times, they create a great deal of change. Or, because I'm saying change in effect, but I want to say just a phenomenon. They produce a very definite event, and it may be a definite event when you lose your arm, but it's going to be an even more definite event when you when the cells in your basal ganglia start to dissipate and die, and then you have Alzheimer's disease, and you stop being who you are, essentially, or at least how people know you. The brain, it's self-organizing systems in general. they're so nuanced and complex and entirely relevant to how one should think of cognition and what it means to be human in so many ways, and why the depth psychology movement, though it is not completely delineate, uh, lends itself to delineation, or possibly even tenable or intelligible for most people. It has a place when we're talking about typology and when we're talking about personality, because the brain itself, as an organism, all organisms honestly are self-organizing systems. It seems that all organic, or one could say natural systems, just things that are a coherence and network of rules and parts that govern and churn together to create effects, these things, they're all self-organizing in nature if they arise. They're all self-organizing in their essence if they arise out of nature. And just to know that it's the importance the importance in understanding this is to uh, better understand why cognition appears the way it does, and why human beings, we act and respond to things the way that we do, and why our brain has the type of processes that it does. For the brain to get through the environment and process the information of a self-organizing system, it has to be something that's something like a computer, but not quite like a computer. And so far as this, that the brain has algorithms, but it also has very peculiar, interesting algorithms called fuzzy algorithms that lead it to its conclusions and its abilities to learn and to make predictions and understand patterns within a system. It also allows us to understand why so many processes happen within the subconscious and not the conscious mind. Because reality, it's a self-organizing system, and it's so rich in information and complexity that the normal working memory, just the rational conscious cognition cannot keep up and understand all that's going on around it. This is why I introduced the idea of a self-organizing system into my analysis of Jungian typology, and feel that it has, well, not feel, but literally think and reason out that it has a very significant basis in understanding typology and what it means, because ultimately it has a very significant basis in understanding what it means to be human. And it's this question of what it means to be human in its relationship to the individual where I feel that the most meaning and understanding can be derived insofar as who you are, what makes you up, what makes you tick, and what makes you go, because at the very base levels, you're a human being, and that's a very specific thing. Thank you.